Hello everyone, I'm Paul and today we're solving problem 2302, count subarrays with score less than k. So this is a hard problem, but actually the code is quite short. So keep watching until you get the intuition and the approach, and then you can try solve it on your own. So let's start. We're given an array nums and an integer k. And we need to return the number of non-empty subarrays of nums whose score is strictly less than k. For example, the score of this array is 1 plus 2 plus 3 plus 4 plus 5 times 5, which equals 75. So if k was greater than 75, we could add 1 to our result. Now let's go with an example. Let's say we have this array and k equals 10. And let's say, for example, we are trying to get the score of this part. So the score would be 1 plus 1 plus 1 times 3. And this is 9, meaning this array is valid. But if this is 9 and 9 is smaller than k, we also know that this array is valid, this one is also valid, this is valid, and this is valid, and this is also valid. So just with this information, we know that here we have 5 valid subarrays to add to our result. Now the question is, how can we solve this in big O of n time complexity? And the answer is with sliding window. First, we're iterating this array from left to right with 2 pointers, left and right, initially at index 0. And we will have a variable accumulated initially with 0. And at each step, we want to add the current number at the right pointer to our accumulated. So right now it's 5. Now for each step we will check if the current score is less than k, and if so, we are adding r minus l subarrays to our result. So our result is initially 0, and here our score is 5 times 1, which is 5, so we add 0 minus 0 plus 1 to our result. Now our result is 1. So this window was valid. So we have one valid subarray, and that's the subarray we have here in the result. And next we update the right pointer. And now we add 1 to our accumulated. So this is now 6, and 6 times 2 is bigger than k. So in this case we update our left pointer, but before we need to subtract from our accumulated the value at the left pointer, which is 5. So 6 minus 5 is 1. This is now 1. Left pointer is here. And now right pointer minus left pointer plus 1 is 1. So we add 1 more to our result, which is now 2. Meaning this subarray is also valid. Next we update the right pointer and we add 1 to our accumulated, which is now 2. And 2 times 2 elements is 4, and 4 is smaller than k. So in this case we can add this array and this subarray to our result. Meaning we can add r minus left plus 1 subarrays. Okay, meaning 2 minus 1 plus 1 subarrays. So the result is now 4, and we update the right pointer. Now the right pointer is here, and we add 1 to our accumulated, which is now 3, and 3 times 3 elements is 9, and 9 is smaller than k, meaning we can add r minus left plus 1 subarrays to our result, which is 3 minus 1 plus 1 subarrays. So here we add 3 subarrays to our result, and now this is 7. and the valid subarrays in this point are this one, and this one. So let's think about this. Here we know that this array is valid and the score is valid, meaning every subarray which is smaller than this subarray will also be valid, because the score will be for sure smaller than k. So we can add each of those to our result, which is what we did. And from this point, I think you could try to solve this problem, but let's continue. Next, we update the right pointer. Now we add 4 to our accumulated. And given that 7 times 4 is greater than k, we need to update the left pointer. But before that, we need to subtract from the accumulated the current value at the left pointer, which is 1. So this is now 6. Now 6 times 3 is also greater than k, so we update left again. And now 5 times 2 elements equals k. But remember, we need to find scores that are strictly smaller than k. So we update left pointer again. And we subtract 1 from our accumulated, which is now 4. Now 4 times 1 element is smaller than k, so we add r minus l plus 1 to our result, so this is now 8. Next we update the right pointer and we add 3 to our accumulated, and 7 times 2 is greater than k, so we update left. We subtract 4 from here, this is now 3. And now 3 times 1 is smaller than k, so we add 1 to our result, which is now 9. And we update the right pointer. Now right is here, and we add 5 to our accumulated, which is now 8. And now 8 times 2 is greater than k, so we need to update the left pointer. So we subtract from the accumulated 3. This is now 5, and we update left, and we check again if 5 times 1 is smaller than k, and it is, so we add r minus l plus 1 to our result, which is now 10, and we update right. And now we reach the end, so we return the result, which is 10. The time complexity for this one will be big O of n, and space complexity will be big O of 1. So now let's go with the code, and hopefully you will get the idea. First we'll say n equals length of nums, accumulated equals 0, and result equals 0. Next we will start left pointer with a 0, and for right pointer in the range from 0 to n. First we need to add to our accumulated variable nums at right pointer. So accumulated plus equal nums at right. And next we want to check while the accumulated times right pointer minus left pointer plus 1 is greater or equal to k. In this case we want to update left, so accumulated minus equal nums at left pointer, and then left plus equal 1. And next we want to add subarrays to result. So result plus equal right minus left plus 1. And finally we return the result. So this is the entire code. I believe this is right, and now let's submit this and see if it works. So the code works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one.
Bye bye.